Okay, a very good day to all of you. We will move along with our next math concept, which will be the surface area of a cone. You can see our cone right here, and we'll be taking a look at that. I thought I had a pen here, and now I'm not seeing it. I'll just go snag one with the calculator anyhow. Alright, let's get started. The surface area of a cone, you're concerned with two things. You're concerned about the bottom, or if it's inverted it'll be the top, but typically the round part is the bottom. And then of course all around up to the pointy peak. So perimeter of the base here is simply a circle. So a pi r squared is going to be the perimeter of the base, the area of a circle, and then the area around, which is typically known as your lateral surface area, but the surface area of the actual part of the cone going up. Well, you need to know the distance around your circle. You need to know the distance around your circle times your height. Now if this was just a straight cylinder, it would be circumference of the circle times the height, but it's a pyramid. And you may recall something about a pyramid. It gets smaller as it goes up. It's a smaller version of a cylinder, and when we're dealing with surface area it becomes 1/2 of a cylinder. If we were dealing with volume it would be 1/3. But surface area, a cone, the surface area of two cones, provided that a cylinder has the same diameter of circle on either end, kan stå indre cylinder två cones ungefär. Okay, so we do the circumference of the circle times the height and then divide by 2. Okay. Let's have a look on the next page here. Got your lateral area going around, add the base area, that's your surface area. So for a right cone, you have pi times radius times the slant height, add pi r squared. So pi times the slant height times the radius. No, this doesn't quite jive. Their formula doesn't provide a whole lot of clarity. Okay, I'm gonna sketch a cone, and we're gonna do one right now. The heck with their example. Surface area of a cone. So here I have my cone. I have a circle with a radius of 3, and I'm going to have a slant height of 6 going up. Okay, so how do I now find the surface area of this cone? First I do the area of the circle. Area of base circle. Simply area equals pi r squared. Pi times radius, which is 3, times 3. So essentially you're dealing with pi times 9, right? 28.3 if I round it off. And I'm going to pretend this was in centimeters. I don't know what kind of unit I was using. Centimeters squared. Surface area is squared. If we were doing volume, it would be cubed. Now, the top of our cone here. We have a slant height of 6, a radius of 3. We need the diameter of the cone all the way across. So the diameter is 6. And how do you find the circumference of a circle? We need to do that first. C equals diameter pi times diameter. C equals pi times 6, and that equals pi times 6. 18.8. So there's your circumference times 6, because that's the slant height, 113.1, divide by 2, because you're going up to a peak, so it's not like a regular cylinder. .5 centimeters squared. Now, I take the area of the base, 28.3, and the area of the cone around, 56.5. 28.3 at 56.5. .8. So this is now for a cone where we knew the slant height. Let's look at a couple of examples where we don't know the slant height. I'm going to grab this one from page 32. I'm going to grab it from there. In this case, we have the radius of our circle, which is 2 feet, and we have the straight height going up the middle, which is 7 feet. We want slant height, right? So what are we going to do? A squared plus b squared equals c squared. Pythagoras, right? 2 squared plus 7 squared equals c squared. That becomes 4, add 49. You should know Pythagoras like the back of your hand right now. 53, 7.3. So we have a slant height here, slant height 7.3. Sorry about my messy 7 over there. Okay, now we can go ahead. So let's start with our circle on the bottom, pi r squared, the radius is 2. A equals pi r squared, pi times 2 times 2, so pi times 4. 12.56 or 12.6. Now again, we're going around the circle times the slant height, divide by 2. So going all the way across here, our diameter is 4. So C, circumference of the circle, equals pi times 4. Pi times diameter. .6. 12.6. Now we take this and multiply by the 7.3 slant height. Interesting that the area of the circle and this original area is the same. Circumference and the area are the same. That only happens when you have a radius of 2, I believe. Might be some other situations where it happens, but they're pretty rare. 91.7. The two answers that we add up now become 12.6 and 91.7. Oh, I forgot to divide by 2 up here. Sorry. .7 divide by 2, 45.9. Might as well put a fresh line here. 12.6 add 45.9. 58.5 square feet, which is the answer they have in the book there. We're good. Using a slightly different method from the one that they're using because I don't like their method very much. It doesn't really explain what's going on. So, we now have another example here that we're going to do for a cone. You'll find this one on page 33, and this time you have an upside down cone. The radius here, here. And we'll have, in this case, they're giving us a diameter of 10, and they're giving us what? The sand hill. Oh, they're asking us to find the height. Well, we're not going to do that. They're asking us to work backwards and find the slant height. We're not going to do that. We're going to say we already know the slant height to be 13. Okay? 10. So let's do the area of the circle first. Pi r squared. Pi times, this time we have a diameter. Half of 10 is 5. Pi times 10 times 5. Pi times 5 times 5. So pi times 25, 78.5. And now we're going circumference equals diameter 10 times pi. 10 times pi. $31.4. Times height, 13, 408.4. Divide by 2. 204.2. Put a box around our two answers and add them up. 204.2 and 78.5. I forgot my units. We'll say they were centimeters. Add 78.5 here. 282.7 centimeters squared. I think 3 examples for this should be enough. So this will be a very brief recording for you on Monday or Tuesday, whenever you get to it. So let's just give you a few exercises to do. I'm going to keep it simple. We're going to stay on page 34, just like the lesson on surface area. So we're going to do 6, A and B. We're going to do 8, B. And maybe one more. 11. 6, AB, 8B, and 11. So let's look at those exercises. So 6 is a couple of cones where they're giving you the slant height, so you won't have to use Pythagoras to find that. Let's find the circle, find the top, and you're good. Here's 8B right here. They're giving you the straight height, so first of all you need to use Pythagoras to find your slant height. After that it'll be the same as 6A and B. And then 11 is a word problem. He built a cone-shaped volcano for a school science project. The volume has a base diameter of 32 centimeters and a slant height of 45 centimeters. So you're finding the area of the whole thing, right? First the circle, you can draw it for yourself. Circle on the bottom, cone, slant height 45, diameter 32. Use the usual formulas to find the surface area. And once you have your surface area, what's it going to cost if paint costs $1.99 a jar and the jar covers 400 square centimeters? Well, first of all, you'll need to know how many square centimeters of paint you'll need. Take that number, figure out how many jars you'll need to buy to cover it. If it's less than 400, then $2 will cover, but if it's more, right, that's for you to figure out. With that, just a very brief recording, less than 20 minutes, a bit of homework, but there will be another recording coming up later in the week. So that's all for this one. Click, click.